All right, let's go ahead and talk about Coulomb's law. Coulomb's law is actually going to be something that we use several times throughout the year, and it's essentially kind of like how gravity works. So let's go ahead and talk about that. So Coulomb's law talks about the attraction and repulsion of charged particles, and so it explains the electrostatic attraction and repulsion, and is often referred to as the inverse square law. And so we'll talk about that in a moment, but essentially, if you think about like magnets, if you have the north side of the magnet and the south side of the magnet, those ends will actually attract each other. So if you have opposite ends of magnets, opposites attract. But if you flip a magnet around and you put the same ends of the magnets towards each other, they actually repel each other. And so this is kind of how it works with charged particles. If you have a positive charge and a negative charge, those will attract each other. If you have a positive and a positive, those will repel. And if you have a negative and a negative, those will repel as well. So let's go ahead and talk about Coulomb's law. So it applies to charged particles. It also applies to magnets and gravity. However, we're going to talk mostly about charged particles, and we're interested, it talks about the force of attraction and repulsion, but what we are actually interested in is the energy of attraction and the energy of repulsion between charged particles. All right, and so essentially we are going to end up with this equation here, where we have energy is equal to the charges multiplied by each other divided by the distance. And so we're going to talk about how the force of attraction or the energy of attraction or repulsion is affected by the charge and the distance. And so let's go ahead and look at this example here. If you think about having a large charge, I want you to think about having a large magnet versus a small magnet. If we have a large magnet, we have two large magnets, the force of attraction between those two large magnets is going to be greater than the force of attraction between two smaller magnets. Now, think about this when it comes to charge. What if we have a lot of positive charge and a lot of negative charge? Well, if we have a lot of positive charge and a lot of negative charge, that's going to be a large attraction compared to a little bit of positive and a little bit of negative. So the little positive and little negative will still attract each other, just not as much as a large positive and a large negative. So the larger the charge, the larger the force of attraction or repulsion. All right, the next thing we want to talk about is the distance. All right, so I want you to think about a magnet again. What if you have two magnets and you bring them closer together? What happens to the force of attraction as you bring those magnets closer together? Well, as you bring them closer together, you can feel that they actually attract each other more. Think about gravity. Can you feel the moon? Can you feel the gravity of the moon? And from here you can't. However, we can see that the moon has a gravitational effect on the Earth with the tides, because we have high tide and low tide because the moon is pulling on our oceans. However, if you were to get closer to the moon, would you feel the effects of the moon? And the answer is yeah. So if you were to go to the moon, you actually would experience the gravity of the moon, versus here on Earth, because the moon is so far away, we don't actually experience it in the same way. And so that being said, as two things get closer together, their force of attraction or repulsion gets larger. And so again, if you think about magnets, you bring two magnets together, they will eventually get to the point where they really attracted to each other, and they'll even maybe rip out of your hand. Or you can feel that if you're putting the same end of the magnet towards each other, as they get closer, you'll feel a stronger force of repulsion. So that's it when it comes to Coulomb's law. It really comes down to two things. Larger charge means a larger force of attraction. However, larger distance means a smaller force of attraction. So it's the opposite with distance. In other words, a smaller distance, a greater force of attraction. And eventually we'll talk about energy, how that relates to energy, because if you have two large charges, it's going to take more energy to remove them from each other, to separate them. And so that's it. Hope you have a great day, and watch these guided practice video for this as well.